This was the first flight of Pete's new plane. Pete had worked hard building the plane. Now he wondered if something was wrong with the design. But his friend Jack Worthington said he thought it might have crashed because of a little wind. Pete didn't see how it could be wind. The leaves in the trees weren't moving, but still he thought twice before arguing with Jack.
After all, Jack has his own airplane. And a private pilot's license. And a pilot has to know about winds. He studies the wind and plans his takeoff, so it's into the wind. In the air, he has to study wind speed and direction, because wind changes his speed and may drive him off his course. No, I won't argue with Jack. But I don't see why he thinks there was a wind. Maybe there are some kinds of winds I don't know about. Anyway. And what causes winds?
While Pete was telling his father about the accident, he saw something that tipped off the answer to some of his questions.
The cigarette smoke going up the lamp. Air must be moving that way. A little wind moving around the lamp. A little wind moving around. Moving around the radiator, too, when it's on. Last winter, Sis was playing with a piece of milkweed down. There was a wind blowing up from the radiator. But what caused it?
Pete went on to learn the answer. Air over a radiator is heated. It expands and becomes less dense, so the heavy cold air about it pushes it up. Now, the cold air which moved in is heated and it is pushed upward. As warm air reaches the ceiling, it cools gradually, becoming heavier and settling down to the floor. Thus, a continuous circulation is set up. This is a very gentle wind. Stronger winds are made in chimneys.
Our fireplace works the same way. Fire makes the air inside the chimney hot. The colder air in the room pushes in at the bottom of the chimney and pushes the hot air out of the top.
After Pete had found out how winds are set up indoors, he asked Jack Worthington to explain about similar winds outdoors.
You see, Pete, on a hot sunny day, a bare field may be heated a lot more than the woods or swamps around it. Then, the air above this field is warmed. It becomes lighter and it's pushed upward by the colder air around it. When a plane runs into one of these rising air currents, it's momentarily lifted. That's what makes bumpy flying.
Say, maybe a wind like that bumped my airplane and made it crash.
But there was more for Pete to know about these rising air currents.
Rising air currents are responsible for some types of clouds. If the hot air from the ground is pushed high enough, some of the water vapor in it condenses out to form clouds. These are called cumulus clouds.
Look, those clouds look like trouble.
Yes, we're in for a thunderstorm.
Thunderstorms occur most often on hot summer days. Air near the ground becomes hot and moist, much lighter than the cold air above it. Suddenly, the cold air begins to fall, pushing the warm air upward. Moisture in the rising air makes clouds and rain, and sometimes hail. The air currents move more and more rapidly until sometimes they travel faster than 100 miles an hour. The cold air strikes the ground with great force. After a storm like this, people sometimes say the rain has cooled the air. But now Pete knows differently.
The cool air came down from way above the earth, and the rain didn't cool the air. It was the cool air that caused the rain by pushing hot, moist air upward.
A few weeks later, when Pete visited some friends at the seashore, he discovered more about winds. It was a sunny day, and a cool wind was blowing across the water toward the shore. Pete and his friends had to fight this wind to get their sailboat away from the shore, while boats coming in had easy sailing. But the wind which came across the water during the day died down in the evening. After a time, a gentle breeze from the land began to blow across the shore toward the water. Again Pete wondered.
What causes these winds?
But now he knew enough about winds to figure it out.
On a sunny day, the land and the air above it become hot. Cool air moves in across the beach and pushes this hot air upward. At night, the land and the air above it cool off quicker than the water. So now, cool air from the land moves across the beach to push the warmer air upward.
Observing the movement of small winds along the seashore led Pete to get some books from the library to investigate the great winds of the world. For the cause of these winds, we must look first to the equator, and for now, we'd better look at it this way. As the sun beats down constantly, the air at the equator is heated and forced upward by the cold air on both sides. The cold air which blows in is heated, and it rises.
It's the same kind of circulation we have around a radiator.
It's easy to understand that air near the Earth moves toward the equator, and air high above moves away from the equator. So if the Earth were standing still, its major winds would be north and south. But the rotation of the Earth makes the winds curve. Near the Earth, the winds curve until they appear to come from the east. High above the Earth, the winds are curved until they blow from the west. Usually, we're more interested in the low-level winds from the east, called easterlies. Such winds had a large effect on trade routes in the days of sailing ships. So Pete learned about the two regions of major winds called the easterlies, which extend around the world and are caused by unequal heating of the atmosphere. But these are not the only major winds of the world. Notice that cool, heavy air is continually pressing toward the Earth along two belts, one north and one south of the equator. This pressure squeezes other air toward the poles, producing another set of winds. Just as the Earth's rotation curves the easterlies, it curves these winds until they seem to come from the west. So they are called westerlies. The westerlies have played an important part in the history of aviation.
That explains why you can fly to Europe a lot faster than you can fly back.
Pete saw that the United States is in the region of the westerlies.
That means that the winds around our house ought to come from... There's one way to make sure.
Anyone can build a wind vane just as Pete did, and study the winds that blow around his own house.
Well, she is blowing from the west.
But Pete knew that one reading was not a true test. He was going to keep a record of the wind direction each morning and afternoon for 2 weeks. Usually, the vane pointed in a generally westward direction. On some days, especially just before a storm, the wind came from a different direction. That's because the westerlies don't blow as steadily as the easterlies. However, at the end of 2 weeks, Pete had conclusive evidence.
The book's right. The winds around here do usually come from the west.
We have followed along with Pete as he discovered some of the facts about some of the important winds of the world. But there are many other winds and many other facts which we have not discovered. Do you know the effect of winds on weather and on growing things and on our land? These and many other things are affected by the unequal heating of the atmosphere, which causes winds.